So now we will move on to measures of spread or variation. And there are a few ones we can use. We could use the range, which is very simple. Maximum, or your highest value, minus the minimum, or your lowest value. So for example, if I give you 1, 5, 7, 8, 12, range is equal to 12 minus 1, which is equal to 11. The second one be the interquartile range. And this is given by the formula upper quartile minus lower quartile. So this word quartile, hopefully you will be hearing that word quartile and be thinking of the number 4, or quarters. And you would be right, because when you have a data set, this is your median, and the median of the lower half is going to be your lower quartile, and the median of your upper half is going to be your upper quartile. This is your max, this is your min. And so what you do is, if you have your data set, your median is going to be this number, 11. Now this is the case where you've got an odd data set, and then you would ignore the median, and then to try and find your quartiles, you'd remove the median and then take the medians of the two halves. So here we have 5.5 and here we have 15.5. Then an even data set, so you've got, well, pretty much, if we just do the same thing again, but just leave off that 18, we'll find that we have our median here at 9.5, and as you know, you leave out your median and then just find the median of the lower half, 5.5, and the upper half, 13.5. So here in the first data set, our IQR will be 15.5 minus 5.5, which is equal to 10, and here it would be 13.5 minus 5.5, which is equal to 8. But there is another way that we can try to figure out how spread out a data set is. The variance. And additionally, I should note for your quartiles, this is ungrouped. For grouped data, estimate LQ at n over 4th value and UQ at 3n over 4 value. But anyway, continuing back to variance. So the variance is kind of somewhat an average of the distance from the mean. So we could do this. We could try to do a sum of x minus x bar over n, but then we could arise problems with, could get a negative. So we could try and work around that. We could try to do, well, the modulus, the absolute value. But this is hard to work with algebraically. So instead what we're going to do is we're going to square it. Over n. And that's what it is. So this is your variance, also known as your sigma squared. And that's the formula. However, this is fairly tedious to work with. So generally we actually use this formula, this easy to use formula. Sum of x squared over n minus x bar squared, and that's the mean. So why don't we try to prove that? We'll say our left hand side equals sum of x minus x bar squared over n. And I'll just note down that we're trying to get to this. So what we can do is we can expand this bracket. X squared minus 2x squared plus x bar squared over n. Then we can kind of split up the sum. Then we could factorize that second term, pull the 2x out. And then we can kind of simplify that a bit, because apologies there. So we extract that 2 times x bar, and we're left in the bracket the sum of x over n, and we know that's equal to the mean, so that we can just write that as 2x bar squared, and plus again x bar squared over n. Now this next one, we can focus on that last term now and remove that x bar squared and leave the sum of 1 over n. And what this summation means is we've got n values of x, because the x values represent each value in our data set. And we want to keep, and this one here, this thing here with that sum of 1 over n, that's telling us, okay, add up 1 for every data value we have, then divide it by n. And how many data values do we have? N, right? So this is just going to end up being n over n, which is 1. So we've got sum of x squared over n minus 2x bar squared plus x bar squared on its own. And hopefully you can now see we have arrived at our new formula. So that's equal to right hand side, and we can go QED. Nice. Now here's a problem with variance. Small problem with variance, easily solvable. It's because we are squaring, the units are also going to be squared. So, for example, if you're trying to do variance in fingernail length, that would have units of millimeters squared. So how do we solve this? We just square root variance, and this gives us something called the standard deviation with the symbol lowercase sigma. So therefore we can just say the standard deviation is going to be the sum of x squared over n minus x bar squared. And this will have the right unit. So standard deviation of fingernail lengths would be in millimeters, which would make things easier, more useful with the in terms of your data set. Now, how do you know with your standard deviation how varied it becomes? What you can do is you do your standard deviation, divide it by your mean. This is called your CV, or your coefficient of variance, and you kind of turn this into a percentage. And so if it's greater than 30%, this is highly varied. So if your standard deviation is more than 30% of your mean, then it's quite varied. So again, we've got a few different ways of finding our spread or dispersion. But what are the advantages and disadvantages of each one? How can we choose which one to use? So for the range, it does treat each deviation equally, and it is very easy to calculate. And for that first one, it's the same with the IQR. It treats every deviation equally. And but the disadvantage of the range, it's affected by extreme values. But for the IQR, it's mostly unaffected by extreme values. So in general, the IQR tends to tell you a more accurate story about the spread. But the problem with calculating the IQR, the calculation is a bit harder because the values must be ordered. And the IQR does not account for all values. And to be honest, neither does range. And for both of them, hard to do further calculations. Then for the variance and the standard deviation, the values do not need to be ordered. As long as you add all of them together, you'll get the same variance. And so this will make it, these sorts of things, variance and standard deviation, easier to work with algebraically and it accounts for all data values. But for the disadvantages, it does give greater emphasis to larger deviations because of the squared in it, and it's far more affected by extreme values than the IQR. Do lots of practice.